All right, good morning, everybody, and thank you for joining us on this online Microsoft Reactor session. My name's Dean Bryan, and I'm a principal cloud security advocate here at Microsoft, which means that I work with the technical community and the security community to help understand how our products are being used and how we can make them better on behalf of our customers and engineers like yourselves. So in this session, I'm just going to dive into how a little bit about serverless, just as a bit of a primer for those on the call that haven't used it before. So please bear with me, those of you that have used it a lot. And then we're going to dive into how we can maybe make those apps more secure, but in a fun way. We're going to do it by showing you how easy it is to attack a badly secured serverless app on Azure. So we're going to have some fun with hacking some serverless apps on Azure. So I hope this goes well. I did put a post, an announcement in the session just to ask people who's used serverless before. So I don't think you can reply to that, but just hit a like and let me know if you have. So I noticed a few people have done that already, so I appreciate that. So let's kick off. So the first thing I want to do is just give you a quick primer on Azure Serverless, because if you've used serverless in other cloud providers, it might be a little bit different to what you have experienced or used before. So first things first, there's a shared responsibility model in the cloud, and we've all seen models like this before, where it kind of goes from on-premises all the way through to VMs, containers, serverless, etc. on the right. I really like this example from Tal Melamed. Tal is the owner of the OWASP Damn Vulnerable Serverless app project, where there's a readily vulnerable serverless app that you can deploy to the cloud, and he's a very knowledgeable person in this subject. And the one thing I really want to draw your attention to is on the right hand side there, where we have application and configuration. That's really what we care about when it comes to serverless. So during this talk, I'm going to focus on two different types of things that we can fix to make our applications more secure, right? So we can always find vulnerabilities and security flaws in our code, and we can also find them in our configuration. And they're the two main places where we're going to find them. There's probably one more that I would call architecture, maybe, in the way that we tie some of these serverless applications together. But I think a lot of that falls into misconfiguration as well. So we'll just focus on the two, code and configuration, today. But before we do that, let's look at what the Azure Serverless platform is made up of. So let me quickly just kind of expand out this thing, so you don't have to wait for my 90s style animations to fold out. It just keeps going, just keeps giving this doc. Cool. So so this is what the Azure Serverless platform looks like. It's probably a bit better to look at it like that. We have got these three products in the middle there, which I would call as serverless products. So we've got Azure Functions. This is the ability to execute our code based on events or triggers that they're sometimes referred to as. So this is things like HTTP trigger, of course, but things like an item being added into storage, something being dropped into a queue, an update in a database or something like that. We can trigger a bit of code. We can also do this based on time-based or recurrence as well. In the middle there is Logic Apps, which is a product which enables us to do workflows to orchestrate processes. Things like this is really used in sometimes off the back of SIEM solutions, such to do orchestration automation. So we could maybe get a security alert, or any alert really, or any kind of event that happens, and we can have this logical workflow happen where we kind of step through a process. It's a low code way of building apps and workflows, but it is serverless in this fact that we only pay per request. And then lastly is Event Grid, which is a pub sub type system for managing events and distributing events around your architectures when it comes to integration. So they're the three products I would say are truly serverless. That means that they scale independently, there's complete abstraction of servers, and then they've got micro billing, you pay per use. There are a bunch of other services, those at the bottom there that you can see, such as database storage, some security tooling, etc., and so on, that help us make up serverless applications, but they aren't truly serverless services themselves. Maybe there's like they don't meet those three characteristics that I just said of scales independently, complete abstraction of servers, and micro, like pay per use billing. So for example, storage is a good example of that. There's a fixed cost based on storage that stays around there. You don't just pay per request to that storage. So that's an example of something where it complements our serverless services to build overall serverless architectures, but it isn't truly serverless itself. So I just wanted to highlight the difference there. And then obviously there's a bunch of tools to help us develop, right? We've got DevOps tools, support within IDEs. I personally use Visual Studio Code, massive fan of that. So there's plugins there for functions and all of these kind of tools, storage and databases as well. But in this session particularly, we're going to be looking at Azure Functions, which is the most common serverless component that we have in Azure. So this is really going to help us understand how we can secure Azure function-based apps, and particularly HTTP triggered-based function apps. And I'll talk a little bit more about that in a while. So let's look at Azure Functions and understand it. This is the basic anatomy of a serverless application on Azure. So in Azure, if you're not familiar, everything resides within a resource group. All right, this is just a logical container in which we hold our resources. Within that resource group, we could have a function app. We could also chuck our storage in there, our database, and I like to couple things that are related to a similar app or a similar deployment into a single resource group. And it's a feature that I really like because it means I can just, especially in my job where I'm building lots of demos and stuff, I can just delete stuff when it's done. So that's really nice for me. But let's focus on Azure Functions. So within that resource group, we have a function app. Now, this is where it might differ to other cloud providers that you might have used before. If you've maybe used AWS Lambda or Google Cloud Functions, this concept of a function app. So the function app is important to understand what this is. This is common for a lot of things. This is our unit of scale. When we have things like cold starts in functions, which means the initial start takes the initial request takes a little bit longer because we're warming up the underlying instance for you. Cold starts are at the function app level. They're not at the function level in Azure. So this brings some benefits, but it also brings some security considerations, which is why I'm mentioning it in this talk. So one benefit is that we can have a number of functions within a function app. We can then, from the cold start argument that we spoke about, if we have a bunch of different methods, get, post, put, delete, our delete method rarely gets any requests, but our get one gets loads. Well, then it's always going to be warm when we do get that rare delete method. If we had a single function app or a single function that didn't have this model just for deletes, then it would always have a cold start when somebody tried to delete an item. So there's some benefits to it, but we also need to remember that this function app shares an identity, and we'll get onto that in a moment. It shares, it's the unit of scale. It shares a /temp directory, which enables us to store some temporary files. So you need to have some considerations from a security perspective when you're thinking about how you manage these function apps. I know someone just asked if there would be a copy of the slides. Yes, we can provide a copy of the slides, no problem. So before we dive into identity and stuff, it's good to understand the functions program model. And I apologize if being the guy from Microsoft coming and delivering a bunch of JavaScript code, there won't be any C# demos, unfortunately. It's not really my bag. But there is this is an example in JavaScript, and it's very similar. The program model is very similar in other languages as well. But ultimately, what you can see on the right-hand side here, we have this function.json file. What's interesting here is if you've deployed stuff into Azure before, your resources are deployed via ARM, right? The Azure Resource Manager. And we can use ARM templates and stuff to deploy them. With Azure Functions, your function app is the resource. Your functions are actually defined just as a JSON file. So we put our function config within this JSON file here. So here you can see that we this is a queue-based function. So we have these bindings. We have an input binding where you can see the top one there, the direction is in. This means that it's an input binding. And then this basically says that when an item gets added to the queue name prime number input, using that connection string there, which is an environment variable within our function app, then we want to use that as the trigger for our code. We can then leverage that context, that binding object on the left-hand side, as you can see in the first line there, where we've defined a variable or a constant called number, and we've used context.bindings and then my queue item, which is the name of that binding that you see there. So we can grab the data from that trigger within our code really easily. Likewise, the same happens for the output bindings. In this case, we're writing to Cosmos DB, to our database. You can see that that is called prime verification document. And rather simply at the end there, we've just defined a payload in this code on the left with some JSON information in it. But if you look at the second from last line, we're just writing context.bindings .prime verification document equals payload, which is basically saying chuck this payload into that database. Now, the reason I like this is because it abstracts our data connections to our triggers and our outputs away from our code. So we could change that backend database in the function.json file, and we don't have to actually edit any of our code. This is really handy for managing different environments like dev and prod, etc. We can keep the same code. We could have our prod database and our dev database, for example, with different bindings and different function.json, but running exactly the same code. So this is a nice little feature, but it's interesting to know that we define the configuration of our functions on a function.json, and then we reference the stuff within that file via the context object, which is passed into our function. Now, that's probably as deep as we're going to get from a development level right now. So I wouldn't worry too much about it if you're watching this and you're not a developer and you're from an ops perspective. One other thing to note is the file structure that we have. So I have this folder here called SLS-sec.js, so Serverless Security.js. And then within that function, that's my function app, and within that I have a directory there called SLS-sec.js with a function.json and an index.js file. This is basically how we define a function. If I wanted to add another function to this function app, I don't need to use Azure Resource Manager or ARM or anything like that. I just add another directory in my source code and then deploy that to my function app, and I will have another function within my function app. So it's slightly different to how you may have done it with other cloud providers. We can just define everything here within our source code just by adding an extra directory. As long as it's got a function.json and an index.js file, it's going to become a function within our function app that we can then trigger based on the triggers we define in that function.json file. Just a quick pause at the moment. I noticed a couple of questions coming in. This is great. If you've got any questions or anything, obviously we aren't in person right now, we're online. So do feel free to chuck them into the Q&A session. I'll be happy to answer them as we go along. All right, so we've got an idea of what functions is, right? We're going to give it a trigger. We're going to execute some code to do something with that trigger, put something in a database or whatever it is. And then we understand that the file structure there as well. Now, identity. Now, this is the best diagram that I could find for identity in Azure. It's called Azure Managed Identity. This is actually an example for virtual machines. But let me kind of explain to you how it works. The fact is that you've got an extension, a little managed service identity or managed identity extension that runs on the underlying instance of our function app. And then when we want to request access to secure resources, maybe we want to get a key from a key vault, or we want to access some Azure resources like a storage account, our code can query that identity on the machine. It's a local endpoint that they query. It's on part of the metadata service, so it's that link local 169 address. So they query that address, and then assuming that that address, that local, that identity that's assigned to that function has the right permissions, it will present them back with a JSON web token, and then they can then use that JSON web token to go and access the relevant service, whether that's accessing storage or accessing key vault. This gets rid of the problem of us having to store any keys in our code, right? We can store our keys in key vault, right? But then we need to store a key to the vault in the code, right? So managed identity means that we don't have to do that. This works similarly to EC2 roles or AWS roles, as they're now called in AWS, if you're familiar with that terminology as well. It's basically an equivalent service. So we can assign roles and policies to these identities, and then we can assign these identities to our function apps. Now, remember, the important point here from a security perspective is that these identities are at the function app level. So we need to be very mindful of that. All right, so let's get into the fun bit. I don't want to do slides for this whole thing. I'm more into the demos. So our sample application, right? So I've built the simplest application you will ever see. In fact, it's probably more simpler than this diagram even allows, because the user and client application just doesn't exist. I just didn't get around to building it. My front end skills are terrible. So it's basically a function app that has two functions. We've got it's called Speakerville, so we store speaker information in a database. It's got a function called add speakers, where we just add speakers into a database, and then a function called get speakers, where we get speakers from a database. That database is stored on Azure Table Storage. All of this resides within the same resource group on Azure. And a user or client would typically request this via a web UI or something like that, which I haven't built yet. But let's assume, for the purpose of this demo, that I have built that. Now, the function we're going to be focusing on here is the add speakers function. The get speakers function actually doesn't have any code in it. I just put it there because it made it look like a proper app. We're really focusing on the add speakers one for the purpose of this demo. All right, so what would a hacker do, right? They would turn on their, they would put on their sunglasses, they would make sure all the lights are off, and then they'd just type crash override into the machine, right? Well, unfortunately, it's not as exciting as the movies would have you think, right? It's a little bit more boring with that. What would start with a typical hacker trying to break into this type of application? They would start with recon, right? And I had to put this in bright orange word art as best I could, just to make it almost as exciting as the images you see in the movies, or as us normal people would call it, information gathering is basically what they're doing. They're going to go and gather as much information as they can to help them plan an actual attack, or work out what this application might be vulnerable to try and pinpoint their attack methods. So recon is probably one of the most important stages, albeit somewhat a little bit boring when hackers are attacking sites or applications or whatever. So let's go along and let's have a look at how we might do some recon or some information gathering for this particular app. So let me just pull up some stuff. So I'm going to pull up this application here. So I've got a Postman here, which is a REST client, so we can do some API calls to our app. This is maybe similar to what somebody might use. It's much more of a basic version. So I'm just going to send here I've got an example of I'm going to go to my public URL. This is the URL, the API/add speakers. And then please don't go to this if you're on the demo. I'm thinking people are going to start going to this now. You can go to it, see if you can work out what the vulnerability is. There's nothing too secure on there. It's all locked away in a secure, an independent subscription. But yeah, there's not much exciting going on. And I will be shutting it down after this, by the way, for those of you thinking you can play around with it. So here we go. So we go to API/add speakers, right? You can see in the body here that I'm sending some JSON. Now, typically, if I had a front-end client application, I would know the structure of this JSON from doing inspect element in a browser and seeing what was being sent via the XHR or web request to this API, and I'll be able to understand what this JSON structure looked like. I may not have that benefit. I might be able to find something like a Swagger file. So if you aren't familiar with Swagger, it's a way that we can define an API in YAML or JSON. Here's an example of this exact API in JSON. So you can see that there's you can see the add speakers request here, which is exactly what we're targeting. You can see the options that it's respecting, the syntax of the kind of data that it's expecting. So you might find this in a GitHub repository or something like that, or you could have the data from a front-end client app and inspect the request that's going to the back end to understand what that JSON structure looks like. But if we go back to this here, we're just going to go and send a normal request to the app, right? So we're sending Dean, Brian, hello at Dean, some fake postcode, fake mobile number. Let's send that along. And then we've got a 200 OK back here, and it says, thank you for submitting your details, Dean. So this application is working. I've already found one thing out about this application by doing this recon. Does anybody think what it, can anybody think what it is? I found two things out actually by this. If anyone can think what it is, chuck it in the questions and we'll publish it. So, oh, I've lost my mouse. This is exactly what you want to happen. Haha. Right, we'll wait for my mouse to come back while I clicked on the other screen. Always fun. I will, while I'm waiting for my computer to come back to life, the one thing that I've noticed here is that if you look in the request URL there, I've actually been able to access this API on HTTP. Right, I've been able to access it right away on HTTP. No HTTPS. We're not enforcing TLS. We're not redirecting or anything like that. We're not got a 302 back. We are literally being able to hit this on HTTP. Don't do that. That's a bad thing. Somebody said response headers in the chat. Yep. We'll have a look at the headers in a minute. I've completely lost my mouse. Has it come back yet? Oh, this is always fun. Oh, I now have a spinning circle. Right, I'll keep talking while that spinning circle disappears. Let me see if it works on here. Oh, there you go. I can get it from my laptop, which isn't the greatest, but. All right, I'm back now. I've got my mouse back. Sorry, folks. So, yeah, the response headers, that's a good answer. So here you can see that the server here is Kestrel, right? So for those of you that aren't aware, Kestrel is a cross-platform .NET Core server. So this probably tells us that it's running on a Linux instance, because if it was Windows, it would maybe be running IIS. And we could test that by spinning up a Windows Azure function and just understanding the environment a bit better and seeing that the server header we get back there would be IIS, for example. So this gives us some information. The other thing that we've got from this is in the body here is that it's also saying thanks for submitting your details, Dean. So we know that it's taking the speaker name attribute from the JSON and it's sending that back to us as the user. So if we were able to get it to do something malicious, we could probably get it to store it as the speaker name value, for example, in the code, and then have it present that back to us potentially. There's no guarantee that would work, but we know that if there's a way we want to get information out of this system, then we could go ahead and do it that way. So we're starting to find a little bit of information about this. So it's given us data back. It's kind of probably expecting this speaker name thing. We're completely open to HTTP. We can see that it's probably running on Linux. Let's try something interesting. So when we sent that request, we sent this JSON body, right? But let's try and send it with without any body just to see what happens. Let's see if we can get it to error or tell us any information. Let's look at the response body there. Oh, we've got 400 bad requests. Oh, look nice. So we've got some interesting information here. So we've got the fact that it's Azure Functions. It's an Azure Functions host here. We can tell that it's running Node. We can also see where the codes is running on the machine, site, root, add speakers, index.js. And we can also see that it's definitely expecting this speaker name attribute because it's saying the property speaker name of undefined, right? There is no body object, so it can't find the speaker name. So we've been able to find like a bunch of information just by sending 2 requests to this app, right? So this probably gives us enough information that we can look at. So let's head back to our slides and see what we found, right? So we know that it's running Node.js. We know that it's Azure Functions and it's probably running Linux based on the Kestrel server that we got back. We know there's no auth. We didn't mention this at all, actually. This is a really screaming object to us, is that there's no auth at all, right? We can literally just add data to a database. We didn't authenticate. We didn't authorize ourselves. There was absolutely no auth whatsoever. We spoke about HTTPS not being enforced. We know it receives a JSON object, so that's interesting. Is there any kind of vulnerabilities in JSON that we could exploit? And we know that it's expecting a speaker name value. If we don't send that speaker name value, it's going to error. So that's probably something that we need to make sure that we include in our request. So what would our hacker do next, right? What would they do when they had this information? Well, they would go along and they would Google with Bing, right? So we would go to Google or Bing or whatever search engine of your choice you want to use. And I just literally put in Node.js JSON exploit, right? Because we know it's Node.js, we know it's expecting JSON. Are there any exploits that we can try based on that? And the first option that came up out of 440,000 results was this write-up from OPSEC-X on how to exploit a Node.js deserialization bug for remote code execution. So I was like, huh, this is pretty cool. Maybe they're running this vulnerable node module. We all know that there's a bunch of vulnerable node modules out there, and maybe I can try and exploit this to see if I can do remote code execution. Now, I found even more details on the exploit database. ExploitDB is something that is open by the folks at Offensive Security. So it's a really popular tool. It's great if you haven't seen it. It normally links back to any kind of CVEs that these vulnerabilities have, but it gives you basically the exploit code that you need to run these exploits. So if I just go next, just to make it a bit easier for you, how did that happen? To zoom in on that bit at the bottom there, what it's basically saying is that the bit that you see highlighted in yellow there is the exploit, right? This is the exploit in the node serialize module. So you see there that we're requiring this node serialize module. This is actually an NPM module that's sitting in NPM. You can still download and install it. It's got a critical vulnerability, and it's been there since 2017, but it still gets about 2,000 downloads a week. So not a huge amount, but there's probably people that are still using this, unfortunately. And basically, all you need to do is send an object in the JSON. Their one here is called RCE, and then you give it this $$ND_func piece of code to define a function. And then you close it out at the end, and then the bit in purple in the middle is just some JavaScript code. So you can write whatever you want there, and the code that you write in the purple bit will be executed on that instance, right? So this definitely falls into the AppSec category, right? So as long as they're using this serialized or unserialized method within their code, which, surprise, surprise, our vulnerable app might be, we're going to test it out in a moment, and they chuck in a payload like this, then yeah, it should be pretty easy to run some remote code execution on that underlying instance. So let's go hack some stuff, right? Let's go and see how we might be able to do that. So I'll go back over to my browser and apologize. My mouse battery's died, so I need to keep going over to my mouse over here. I've got a walkthrough of the exploit here. So basically, what we're trying to do in this demo is we're going to run some code inside the server using that vulnerability. So in that purple bit that we just saw, we're going to chuck our own code in there that we can have the underlying instance host run for us so that we can hopefully get some information. Now, on the purpose of time, I'm not going to dive into exactly how we would test whether we could get the data back and the speaker name and stuff like that. Let's just assume that we can't present it back to us as the speaker name in the browser or in the Postman client. So we're going to have to get creative in the way that we're going to get data back from the server. So one thing that we can use is ngrok. If people aren't familiar with ngrok is an awesome tool for tunneling traffic from the public web into your local machine. So most people use this for dev environments and testing. So you can spin up a HTTP server on your machine using the command you see at the top there, Python -m http .server 80 if you're using Python 3. And then you can just set up a forwarder for ngrok, say, please forward traffic from the internet to port 80. And it will give you a URL, like a public URL that you can use. We'll see that in a moment. And then what we're going to do in our code is we're going to run some code like this. So we're going to say, we're going to run a function and we're going to say const exec equals require child process. Child process is a Node.js library that's built in. You don't have to install it or download it. It's already built into Node. It's a native library that we can then require in, and then we can basically run that piece of code as a command line on the underlying instance. So you see the command that we're going to run here. We're going to curl, and basically we're going to curl my ngrok endpoint. This is the URL that ngrok is giving back to me. So we're going to curl my web server running on my local machine, and then we're going to pass a query string called data. And then within that, we're going to run a command. So we're going to do ls-la/temp. We're going to pipe it to base 64. We're going to do wrap 0, which means we get all the lines. And then we're going to exec that command, right? So we're going to just run that command on the underlying machine. So we need to pass this whole 5 lines or whatever it is of code into that purple bit that we just saw in the thing. Now, that isn't really that easy to do when you're passing it as a simple API request. So what we'll do is we take the exploit code and we turn it into hexadecimal. So we convert it into hexadecimal here. All right. And then what we can do is in our code here, you can see that I've actually added, I wonder if I can make this a bit bigger. There you go. You can see at the bottom, I've added an attribute called naughty. And then in there, you can see that I've got this is the exploit, right? Remember we saw this earlier, this bit at the beginning? So we need to have that. And then this is where the purple bit starts. And I'm just using the buffer method within JavaScript to just decode that hexadecimal piece of code to a string and then run it. So basically, it may always be to put all that code, or as much code as I want, into one line, have JavaScript decode it, and then run it on a local machine. Now, this is a pain in the backside to write some code, convert it to hexadecimal, decide the command you want to do, update it with your ngrok URL, because that changes every time you run ngrok. So I wrote a little tool, a shell script, which I can also share as well to help do this. So in fact, I can just show you. In fact, I don't really need to show you what it does. I can just show you how it works. So let me pull over my. So this is my terminal here. Make this a little bit bigger. All right, so I've already run this Python 3 server HTTP 80. So I've got a server running on my machine on port 80. I've then done ngrok HTTP 80, and you can see that I've got this ngrok URL here. All right, this is the URL for the local web server on my machine. Oh, that was stupid. Let me run that again, because I did Control-C rather than Control-Shift-C. So I'll copy that. Then I can go here and I can just go. I'm just going to set that ngrok URL as an environment variable. Nice. And then what I can do is I've wrote a little command line tool called generate payload. And you can see here that basically what this is doing here, it's saying generate payload.sh, and it's passing -c for a command. So this is the command, the remote command we want to run on the machine. And then it's got -u, and I'm giving it my ngrok URL. So I'm saying run this command and send the data of that back to my ngrok URL. And then if I go and generate that, it basically gives me a payload here that I can then copy into Postman to run on that machine. So if I copy that over to Postman, I'll look at this one here. That's always good when you delete stuff. This one to do. I can just delete. You see I've now added this attribute called naughty, as you saw in the document. And then within that attribute, I can just paste in that payload. Now it looks like something's happened with the carriage returns there, but let's see if it actually works. So now I'm just going to send that payload to my add speaker. So this should give us the environment variables on the machine and grep for the term MSI. So MSI is where we find the managed identity credentials or the endpoint that we need to query to get that JSON web token. Remember I was talking about the identity, we query that local endpoint. We have to give a key when we query that local endpoint. So this is going to give us back the secret for that local endpoint. So we could run another command after this to then curl that endpoint with get access to Azure storage or whatever this and basically find out what this identity of this instance has access to. So if I send that, oh, I've got a 500. Yeah, I need to fix this a little bit. Bear with me. Go like that. I think I need to delete that one. I'm not sure about this one. That one. All right, so let me send that again. Now I've fixed my. Cool, so it says, thanks for submitting your details, Sally. So I haven't got any information back, but remember what we were doing, right? We were sending that data to our ngrok endpoint. So ngrok has this really nice inspect browser. So you can actually see here that we just had a GET request come in. And look, when they sent us the GET request, they sent us some data as a data attribute. I can copy that into a base64 decode site. I can do Control V and then decode. And ta-da, look at that right at the bottom there. Hopefully you can see that. I've now managed to run a command on the underlying instance for Azure Functions, and I'll be able to get the MSI endpoint and the MSI secret back. So I can then use that to run a further command to curl that endpoint for a particular service in Azure. You have to pass in the service you want access to, like storage.azure.com, and then I'll get presented with a JSON web token that I can then completely stop doing the remote code execution anymore. I've got a JSON web token with permissions to that specific service. I'll show you in here rather than demoing it how it works. So you can see here I've got this, the command that I would do is I would curl, pass in the MSI secret, pass in the MSI endpoint, you give it an API version, and then you say the resource is azurestorage.com, and it would run that command and it would then send that to my ngrok endpoint as base64 decoded, and I would just have to decode it from data, and then I would be able to do that. So literally by one developer adding a vulnerable, doing some reconnaissance, be able to find as much information as I can so I can have an educated guess on what it might be vulnerable to, a developer using a vulnerable dependency that they shouldn't be using. So a number of things all together here. I would be able to get access to the underlying machine and remote code execution. Not looking good. But anyone that works in security knows that the ultimate goal for all of us is to get a reverse shell, right? We don't want to get just sending commands like this. This is a pain. We want to get a reverse shell. So for those of you that aren't aware how a reverse shell works, my attacker machine, which is this Ubuntu machine that you just saw there, I would start listening on a particular port. So I'm going to listen on port 3006 on my attacker machine. And then on my victim machine, which is the Functions app underlying instance, I would run some code, send it another bit of code, because we've got remote code execution, right? That then sent a connection back to my attacker machine and pushes back a shell, basically. So we're going to actually try and open up a shell to the underlying functions instance and see what we can do once we're on there. So to do that, I'm going to use a tool called Netcat. Netcat is a really nice utility to enable us to do that. So I can Control C that. I can close down this web server. Cool. So on this one, I'm just going to do clear, and then we're going to do netcat -l for listen, port 3006. And then ngrok, luckily enough, we can do /ngrok, and then we do TCP 3006. So ngrok supports HTTP tunneling, but it also supports TCP tunneling. You do need to sign up for an ngrok account to get the TCP tunneling, but it's it's pretty easy to get going. So all we need in order to do a reverse shell, because the URL is the same, the only thing that changes here is this port number 16357. I just need to give my generate. I've got another script that doesn't generate a remote code execution, but it generates a reverse payload piece of code and uses that port to connect back to. So in simple terms, I should be able to just, I think I've got this here actually. Yeah, so similarly before, I can run whatever code I want, right? So the code I want to run here is some reverse shell code. I literally got this code off the internet. I literally searched reverse shell cheat sheet JavaScript, and it came back with this code. So we're going to require net to make a network connection, child process. We're going to do child process.spawn bin/sh. So this is our shell. So we're going to spawn a shell rather than run a command. And then we're going to run a new socket, and we're going to connect to the port here, which in this case I wrote 12345 on that URL, that TCP ngrok URL. Now our port is slightly different that we just saw. And then basically we're just going to open up a pipe to my computer on that port, and hopefully what that gives us is a bash shell that we can do. Again, similar to before, we encoded that as hexadecimal online using a tool like this, Hexator. And as before, I've created a simple command line tool to do this, so I don't have to worry too much about it. It's 16357. So what's it called? So it's /gen reverse payload, and I think, let me just run that. It's -p, yeah, -p, and I forgot the port already. 16357. There we have some code, right? This is looking good. This is our reverse shell code. So this is very similar to before, but instead of running a command, we're actually going to pop a shell. So I can go back to Postman. Oh, not that one. That one. I can paste this in here. I've got to fix my lines again. This I've just moved from Mac to Windows. This never happened when I was copying on my Mac, funnily enough. But hey ho. Trying to make sure that I'm not yeah, that should work. Let's try that. So similarly before, we're just going to run this command and it's going to say 200. Thanks for submitting your details, Sally. Again, nothing's happened, but if I come back to my netcat listener here and I just do an ls, ta-da, look where I am. I am inside the actual underlying Linux host that is running on Azure Functions, right? I can do a ls/temp, and we can actually see here that we're writing data for people to the functions, right? So I can do a cat bob.json. Oh no, because I'm not in that directory, am I? You can't use up and tab. It's all old school. So we're going to cd/temp. And I've managed to get Bob's details, right? I can do that same command as before. I can do env grep msi, and I'm able to get those things. So I can then run my curl command, dead simple to run these commands. Now I'm in the machine. I can go back to where am I? Let's go home. So we're back where we started in www root, which we know how to navigate this now because you remember we got that in that stack trace that returned earlier on. So I'm now on the machine. You can see here that there's something in there called list invoices. Wow, what is this, right? And remember I was talking about function app usage, right? Sometimes I've seen people make this mistake where they run unassociated functions within the same function app. This isn't good because now, for one, if I was able to exploit the add speakers or get speakers function, I could access the code for list invoices. I can access any data that is storing into /temp. Maybe it's storing some invoices into /temp as well. I would have access to that. And again, if somebody compromises this function, the blast radius is obviously much more significant. We can look at that if you want. We can look in there. And now you can see that I can just do cat. And I'm able to get the code. There isn't actually any code in there, but just for example, how somebody could do that. So we're actually like in the underlying instance, and we can basically do whatever we want from here. We don't have time in this session to demo it, but the idea is that the identity associated to this function has subscription-wide access, right? So this is us talking about least privilege and giving our applications as least privilege as possible, because we can then go ahead and just access a storage account. This is how like a bunch of the most common data breaches have happened, right? People accessing identities on instances. Luckily, AWS announced the metadata v2 service, which you now have to, similarly to this, pass in a secret to query the MSI endpoint, which helps save from SServ attacks or server-side request forgery attacks, which have been really popular with metadata services in the past. Luckily, in Azure, you have the secret there that you can't really do it via an SServ attack. But if someone's to get access here, and this function had wide access to your subscription or your account, or even to the resource group, they would be able to access storage accounts, list files, and all this kind of stuff. So yeah, really powerful, really powerful ability to start accessing information in the account from here. We could go on for ages doing this, but we really don't have the time. So let's Control C out of that. Let's make sure that we just shut our tunnels down to my machine. Right, cool. Bear with me a second. All right, so what did we find during this this test of our application to test its security, right? We found there was a remote code execution. This is definitely AppSec. This is using vulnerable dependencies in our code. Vulnerable dependencies, AppSec again. There was no auth, so this is really about configuration, a little bit of AppSec, but really configuring authorization. Again, maybe comes into the architecture category as well. HTTPS wasn't enforced. This is definitely a configuration thing. Managed identity is wide open. This is a config thing. We'll talk about least privilege. Secrets were stored in plain text. Oh, we didn't look at that. I've just closed out. But if we would have catted index.js for the add speakers function, you would have seen that there were passwords stored in plain text there and as environment variables on the machine as application settings. Within Azure Functions or Azure App Service, really generally, you can define what are called app settings, which are basically environment variables at that instance or function app level. We had a few of those which had storage account keys in them. We had a few of those in the actual code itself. So all those keys should be stored in Key Vault, and we'll talk about that. The function app boundary, right? That's really under architecture, which I've put there, which is don't put your invoice function app functions into the same function app as public facing stuff that you're using, for example. And the last one is information leakage. You know, when we did that request without anybody, we were leaking a bunch of information that we really didn't have to do, headers, all that kind of stuff. So let's step through each of these in person and see what you could do. This is the secure part of how to secure a serverless app now. So input validation is your friend here. I know there's a JavaScript input validation, like a JSON input validation library for JavaScript that you can use, and you can write your own rules and stuff, as well as use ones that it's got. Adding a web application firewall can also really help here, because that will be able to pick up some really basic types of RCE, but you can also write custom rules, which we'll see in a moment, how you could write a custom rule to protect against specific vulnerabilities that you know reside in your code. Another thing is running web scanners, right? The OWASP attack proxy, as part of your build process. This is talking about DevSecOps, right? You should be running web vulnerability scanners for your web-facing assets. Z-attack proxy is a good example. You can see the screenshot there that there is actually a plugin or an extension, is probably the better term, an app for Azure DevOps or Azure Pipelines. So you can easily integrate this into your pipelines and run this free application vulnerability scanner before you deploy your code to production. Likewise, you should probably be running your configuration scanners as here of things like NCC have built a tool called Cloud Scout Suite, for example, that enables you to do that, which is completely open source. Let's quickly look at the WAF thing, because I think it's quite interesting to dive into that. If I go into here, yeah, I've got a WAF here. So the WAF functionality on Azure Functions is done using Azure Front Door, which is an edge-based application level global load balancer. You can simply turn on the WAF by just ticking a box to say, yeah, give me a WAF with it, and you've got a web application firewall. It comes with a bunch of managed rules here, so a whole bunch of managed rules here. They will find things like, I don't know, like PHP injection, cross-site scripting. There's a whole bunch of SQL injection. There'll be remote code injection here as well. Just looking for any kind of code coming in. Running command lines, all that kind of stuff should be found in here. But also you can write custom rules. So say in this particular example, your developers, you said, look, you're running this vulnerable node thing, serialize, node serialize. What on earth are you doing? And they said, look, Dean, I know we really need to change it, but there's we really can't do it right now. We're gonna have to put it into next release for a couple of weeks out or whatever like that. You could use something like custom rules to build a custom rule and do this yourself. So here's an example here where we say, like, if the string, if the request body contains something, so we know that if it contains this underscore $$ND underscore, we know that that is the exploit for the the node serialization vulnerability that we exploited, right? So if we had this turned on in front of our device, this would actually block our it would actually block the traffic. We could decide to block. There's a few things that we can do here. We can deny traffic, we can allow traffic, we can lock traffic. There's a bunch of things we can do. I don't actually have this turned on in front of my that particular app right now, hence why we were able to do it. But if this front door was sitting in front of the app that we were just using to test, then we would be able to deny the traffic and block this specific vulnerability as well. So really simple to use this rules engine to do, like, if the string in the request body contains this particular value, then deny traffic. Like, really simple graphical way to build these rules and prevent specific vulnerabilities. But of course, the manage rules picks us up for most of the OWASP top 10. So I'd encourage you to turn this on if you can. All right. So what Azure Functions has the ability to do, when we spoke about Auth, is it had the ability for, we had no auth, right? We weren't sending any auth. So you can have proper authorization, you can add Azure Active Directory B2C, which is actually what you should probably do for this. You should authorize users before they can add speakers into a database. But what it also has is this ability to do what's called a function key. So you can give your function app a key, which is a unique string that you can distribute to only people that you want to access your function. So if we added that front door and WAF inside our function app, we would give that front door on WAF the function key so that it would be able to access, and it would be permitted access to the API. And then the actual, any requests coming in trying to bypass the front door or the WAF would have to, would be denied because they don't have the function key that they would need to authenticate that request. So that's a really simple way that you could build this kind of architecture, which is demonstrated here. All right, next one, vulnerable dependencies. At least run npm audit if you're using Node as part of your build, right? You can also use commercial tools for dependency checking, such as Sneak, or White Source. But one thing that's really mad is that I noticed when you run npm install, it actually tells you, like, if I run npm install in this exact repository, you can see there in the highlighted that one critical severity vulnerability was found, right? How many of us actually notice this, right? The other problem is that we're probably running npm install on our build process, so we're not actually seeing this output at all. So adding some kind of auditing is part of our build. You can just run the command npm audit and it will give you all the information about this vulnerability, links to the CVE, the exploit, all the information you need. You could do that as part of your build, or you could just use a commercial tool, whichever is easy for you. But there are free and paid for versions for you to be able to do this. It's a solved problem mostly, so that you should definitely be checking for vulnerable dependencies before you ship your code. No auth, right? So as I said, use function keys as a minimum. I was talking about this when we just spoke about the web application firewall. Use front doors if you're using API gateway, logic apps accessing your functions, etc. Use a function key to give other services access to your stuff. But if you need to do product auth, you should do auth with Azure Active Directory B2C. There are third-party products like Auth0, etc. that you can use. There's an example here of an application where somebody signs in with Azure Active Directory. API management has got the ability to do like a sideways authorization request. So when the request hits the API management endpoint, it will send that request out to Active Directory, validate the user, get a token, validate the user's token, and then pass them onto the function app when need be. There's plenty of articles documenting exactly how to do this. HTTP isn't enforced. Now, this is a really annoying thing for me. I've been speaking to the Azure product group about this. By default, HTTP is turned on by default. So you saw right at the beginning when I did my recon, I hit the HTTP endpoint. You need to go and actually turn this on. So you can go along and press trigger it in the portal or via the API and just turn HTTPS only on. You have to do that yourself. What I would actually encourage you to do is a better way is to use a tool called Azure Policy. This enables us to define policy around what's allowed and what isn't allowed in our subscription. So you can actually write a simple policy here that says if HTTPS only is forced, then do something, right? So block the deployment, right? And the Azure policy runs at the resource manager level, so it will validate the policy before your resources are deployed. So it would not let somebody deploy Azure Function app if it did have HTTP enabled. So it's a nice way to solve that across all of your subscription or multiple subscriptions if need be as well. Managed identity is wide open. We explained this, but we didn't explore it. But you saw how easy it would be to get those MSI token, query that endpoint, and get a JSON web token with some information. We should use least privilege access, right? We should only give our function apps the identity permissions they specifically need, right? Now, a lot of people in Azure will say to you, there's 5 built-in policies, reader, contributor, whatever, to your Azure resources. Use one of the built-in policies. I'm actually not an advocate for that. I think that you should use custom policies where need be. One thing that you can do is you can run this command in the Azure CLI. If you don't have the Azure CLI installed, you should use the Azure Cloud Shell. This is a built-in shell within the Azure portal where you can get a Bash or a PowerShell instance, which has the Azure CLI installed already. And you can just run AZ role assignment list, and then you can pass in the assignee, so the ID of your identity, and it will tell you all the roles that identity has got. So you can then go ahead and see if you need to tighten stuff up, etc. If it's got wide open access, it's a good way to audit it. I'm actually working on a separate side project, which I'll be publishing as open source for Azure Functions least privilege checker, which will basically do this as a kind of script across all your function apps and generate a report. But it's a few weeks out from being ready yet. But yeah, ultimately there will be, keep an eye on my GitHub, etc. There'll be a tool, or follow me on Twitter. I'll publish a tool for that very shortly. Secrets stored in plain text, right? You should always store your secrets in Azure Key Vault. In application settings, so the environment variables in your code, you can actually use what's called Key Vault references. Now this looks like a bit of a mouthful, but basically, rather than giving your, you can give an application setting any name, so Dean's key, and then you give it a value that looks similar to what you see on the screen now. So at Microsoft.keyvault secret URI, and then you pass in the URI of that secret in your Key Vault. This means that then all that managed identity back and forth that we just spoke about, you know, where you have to query the local endpoint, get the identity, curl the Key Vault, get a JSON web token, then query the Key Vault for the key. Azure Functions will handle all of that for you if you reference your application settings like this. So it's a nice way that you can store your keys in Key Vault, give your function identity access to the Key Vault, and it will take care of all that kind of handling that process for you under the hood. If you reference your application settings like this, then you can just reference Dean's key in your code and it will go and retrieve it from the Key Vault and give it back to your application when needed. The function app boundary, we spoke about this, right? Function app share identities, application settings, and underlying physical host. They share a deployment endpoint. This is one thing that people seem to forget, right? You see people deploying into functions from VS Code extensions. You see them doing it in the portal. People have triggered deployments from Git or from their pipelines in DevOps processes, etc. Well, the deployment endpoint is exactly the same for all functions in a function app. So that's something you need to think about. They also share a /temp directory for the lifetime of that underlying instance. That will eventually die off, but it's an interesting point. If you're both writing to /temp, then the other functions, function A can access the data from function B. And scaling, they're a scaling endpoint as well, so they scale together and scale down together, which could be a good and could be a bad thing, but it's just something to bear in mind when you're architecting your serverless apps. Information leakage, right? Just do proper exception handling, right? In Node or JavaScript, you can bind to underscore exception, right? Don't ever return error.stack, which is exactly what I did in that demo app, just to prove the point. And the other thing we can do is we can override default headers with our values. Remember we saw that Kestrel header come back from our server? Literally within your function code, you can just do, when you send the response back here, we're using context.res to send that back. Res is the name of that output binding that we saw in our function.json right at the beginning. We're given a status 200, we give a body response back, whatever we want to pass in there, and we can actually overwrite the headers there. So if I did server Billy Bob in this example here, then we wouldn't get Kestrel returned, we would get Billy Bob. So there's some simple ways that you can obfuscate some of the information that comes out from the underlying service. So 5 key takeaways for you. AppSec is AppSec, right? Whether you're using serverless or other applications, then yeah, it's all AppSec, right? Be mindful of non-HTTP invocations. Now, this session didn't really cover that, but I really wanted to labor this point that a lot of the tools that I've even spoke about today in this session, I'm doing a lot of research and investigation into this right now, actually, and I'll be producing some content around this, is that Azure Functions isn't always triggered by HTTP, right? It could be triggered by a queue, a storage account. So with a storage account, for example, you could be vulnerable to file name. If you're using that file name anywhere, you could be like, you could inject malicious code within the file name of a file that you upload, or within the data of the file itself, if your function app is reading that file and passing it like a CSV or something like that. So you need to be really mindful that one thing that I found is that if it's not HTTP, the invocation, we just trust it. Like we just trust it by default. Well, it's only being triggered by Azure Storage or via an email or via a queue or whatever it is. Just be very mindful of those non-HTTP invocations. I think a lot of serverless security is focused right now around HTTP invocations. Like a WAF isn't going to help you there. Adding authorization isn't really going to help you there for a lot of cases. So running a web vulnerability scanner isn't going to help you there. So it's something that I'm doing a bunch of research into at the moment, actually, and I'll be publishing some content on maybe some ways that you can kind of secure your non-HTTP invocations, because it's an area that's really front of mind for me at the moment. But just be mindful of those and don't trust anybody. Basically, apply zero trust methodology and be mindful of that. Do input validation, things like that, even if your triggers aren't HTTP. Adopt least privilege principle. I can't labor this point enough. Only give your functions access to what they need access to. And adopt push left. We spoke a lot about putting stuff into our build pipeline, right? It's part of DevSecOps, right? We should be doing configuration checks. We should be doing credential scanning of our code, static code analysis for security vulnerabilities. We should be doing dependency checking, web vulnerability scanning, all within our build pipeline before we push our code to build, right? Push that security process left and embed it into our software development lifecycle. Implement Azure policy. All of these config things that we saw about HTTP and a few other things, right? You can implement Azure policy that will enable you to check that at deployment time. So deployments will fail if they don't comply to the standards that you have set. And lastly, use Key Vault for all of your secrets, right? Don't be storing secrets in code. Don't be storing secrets in app settings. Store your secrets in a Key Vault of some sort. Azure Key Vault is obviously the most natively integrated for Azure, but there are open source products from HashiCorp, Vault, etc., and a bunch of other stuff. Yes, I did know there was actually 6 takeaways. I just couldn't get it down to 5, unfortunately. So yeah, thank you for listening. You can follow me on Twitter for any kind of future content that I'm producing. We'll be running a bunch more events like this, online events for the Microsoft Reactor. So just where you signed up on meetup.com, there'll be more events coming there as well. If anyone has any questions, then chuck them in the chat. I'll hang around on here for the next few minutes. And yeah, thank you for listening, and enjoy the rest of your day. Let's check the questions now. Someone noticed there was no auto compass in the request. I'm going to like that one. Yeah, and we are recording the webinar as well. Hopefully everybody was able to see it. Somebody was reporting that they had some buffered content at the other end. It's a bit blurry, so hopefully everyone can see it. Let me know if you couldn't. We can always make a separate recording as well. And somebody should, yeah. Thank you for listening, whoever just sent that question as anonymous. All right, so no more questions coming in right now. Let me just double check. No, so with that, we'll call it a day, and thank you for attending. I really enjoyed it, and hopefully see you at another one soon. Thanks.